Okay, so we're back on implicit differentiation, section 2.7. We left off on example 4. It was a real quick second video, part 2, and I just went over one example. And now I'm going to go over example 5 and finish this lesson off. So find the slope of the graph of 2x squared minus y squared equals 1 at the point 1, 1. So this graph of 2x squared minus y squared is the graph of a a hyperbola. It has two branches. And this is a graph of a hyperbola also where it has two branches, one that you're a little more familiar with. So we're going to take the derivative and we're going to find the slope of the point 1, 1. So we've got 2x here. So I'm going to take and apply the derivative rule where I take the derivative of the first term, 2x squared, and then minus the derivative of the second term, which is y squared, and is equal to the derivative of 1, which is, of course, just 0. So the derivative of 2x squared is 4x minus, then the derivative of y squared is 2y dy dx. Be careful with this. Remember, you have a y. You're taking the derivative with respect to x. So y is some function of x, so you must use the chain rule for that. Just think a quick, easy rule is if the variables are not the same with respect to x, and then you see your expression is a y, then you're going to have to use chain rule with that inner function. So now we want to isolate. So our method is that we get all the dy dx's on one side of the equation. So we want to leave the negative 2y dy dx on the left, that term, and then we take the negative 4x over to the other side. Of course, we can use our double negative rule here. So now we divide both sides by 2y. So dividing both sides by 2y, and we get our isolated expression. The 2y's cancel here. We get dy dx is equal to 2x over y. So now what we want to do is take our dy dx, and we want to evaluate that at x is equal to 1 and y is equal to 1. So that's 2 times 1 over 1, and so that's equal to 2. So we get a slope that's equal to dy dx, or the slope at 1, 1 is equal to 2. Okay, so there's that example. Moving on then, if you need to review that, certainly go back. So using a demand function for a product, the demand function for a product is modeled by P is equal to 3 over that polynomial. And so you can see I have a cubic and a linear term in the bottom. So where P is measured in dollars, and x, remember P is the demand function, and x is measured in thousands of units as shown in the graph. Find a rate of change of the demand x with respect to the price P. So what we're looking for is dx over dP. So with respect to P would be in the denominator of this rate. So what I'm going to do with this equation is I'm going to solve it so that on the left side you get all of your x's, and on the right side you're going to have your p's. Okay, so I want to take ddp of both sides of this equation then. So you can kind of see as I isolate all the x terms on one side and the p terms on the right-hand side. It's just convenient for me to do this. It's certainly not necessary, but it certainly makes it a little easier. So I'm going to take ddp, and you can see the graph if you're looking at the graph and saying, okay, here's the point where we want to find the rate of change of the demand function right here. But we want dx dp. So it's going to be a little bit reversed from what you would see from dp dx, okay? And you can kind of check that out. So here we go. We'll take the derivative on the left-hand side. So what does that give us? It gives us 0.0000001, 5 zeros, right? 1, and it's going to be that times 3x squared plus 0.01. Okay, so that's on the left-hand side. So now you have to remember, though, you're taking the derivative with respect to p, so at the end of all of this, notice I guess let me take it back just a second, just so I don't want to lose anybody. We need a dx dp here plus 0.01 dx dp. And that's equal to, on the right-hand side, we have the derivative with respect to p of 3p to the negative 1 power. So we have a 3 times negative 1. I'll make that negative. So we're going to bring that negative 1 times 3. So we get p to the negative 2 power, right? Now we want dx dp, so we're just going to do a little bit of factoring here. And in this, what do we want to find? We want to find the rate of change of the demand x with respect to the price p when x is 100. So you all are going to have to get a calculator to get the function value. So here we have our 3 times this. So it's going to be 0.000003 x squared. And then it's going to be plus 0.01. And then we're going to factor out our dx dp. And then that's equal to negative 3 p to the negative 2 power, right? So I could pull that down in the bottom if I wanted to, but I'm going to hold off for that. Okay, I'm going to divide both sides by this quantity. So I'm going to divide both sides by 0.00003x squared plus 0.01. Canceling those. And on this side, 0.00003x squared plus 0.01. And so we get our dx dt, dx dp, okay, is equal to negative 3 over, I'm going to put the p squared down here, p squared, and then it's going to be 0.00000. This is why we have scientific notation for numbers like 3 millionth. X squared plus 0.01. Okay, so there's our dx dp. So dx dp is right there. And now what we need is dx dp when x is 100. So now what we're going to have to do is we're going to have to get two values for this. When x is 100, I want to hold it there for just a second. I've got to get my calculator. So when x is 100, we've also, well, I don't really need my calculator. I just need to know that when x is 100, p is going to be 1, because I already have that value. But normally, if we don't have that information, we would have to put in 100 here, cube it, and 100 here, and also cube it and get that value. So in our formula for dx dp, we want it evaluated, of course, when x is 100, but then p is equal to 1. So we're kind of given that I gave you the graph for this, I kind of wanted you to see dx dp. Now, so the slope of what I'm looking at here is a little bit backwards, because here you're looking at delta p over delta x on the graph. So you're going to see that it will reverse itself. So we have a negative 3, and then it's over. And we're going to put this in as p squared. So it's just going to be 1 squared times 0.00003 times 100 squared plus 0.01. Okay, the calculations for this, now this is where I need my calculator. So close in, where am I here? Oh, I'm logged out of it. What do you know? Okay. So I'm going to leave this up to you to calculate this final value, and we'll check together tomorrow, Monday, and kind of check on it. I'm going to let it play out for just a minute and just let you think and see if I can quickly find it. If I can quickly get the value with my calculator. So I'm going to just pop this in there. Hope you all have a nice weekend. It was a very nice video we saw today. And so I have negative 3 divided by 0.00003 times 100 squared. And then that is going to be plus 0.01. 0.01. Close that up. And what do I get for an answer? I get negative 75. Negative 75. So now the units are these are in thousands of units. So this is the demand in thousands of units per, and the price in dollars. Because you got to see that it reverses itself there. So negative 75. So if you look at this, the number as the price goes up, you know, or if you consider this, as the units go up, the price goes down, to make sense. So if the slope is negative here on the graph, it makes sense that the reciprocal, because what you're looking at is dp dx, looking at the graph, the normal way you would look at slope. But in this case, you'd be looking at dx dp, so it's the reciprocal. So remember that when you're using chain rule with any of this stuff, that we use d outer times d inner. And so d outer times dy dx. Okay? So with all of that, or that should be a u dx usually, because we say the u is on the inside. So we have a checkpoint here. The checkpoint answers are, of course, in your textbook. So if you go to WebAssign and you open up your textbook, you can see that at the end of the chapter, we have a checkpoint, or I'm sorry, in the chapter we have checkpoints, and you can see wherever you have those example 1 checkpoints, example 2 checkpoints, there is a drop-down menu, so you can kind of check that out and see what the answers are for that. The next lesson that we're going to touch on then is related rates. It's where we start to apply some of what you've been learning with derivatives and implicit differentiation. So you guys have a great weekend, have a great night, whatever night of the week it happens to be when you watch this video, and I'll see you soon. Take care.